Imagine you're driving down the road. You go to make a turn, you move the steering wheel, and for a terrifying split second, the car just doesn't feel right. Maybe you hear a clunk, a rattle. Something is just deeply wrong. Well, for the owners of nearly 100,000 new Peugeots, this isn't just a bad dream. It's a very real and dangerous possibility. Here's the number, 95,767. That's how many brand new Peugeot 3008 and 5008 models are being recalled. And the reason? It's a potential failure in one of the most critical safety systems any car has. It's steering. And you can see just how this thing can escalate. It might start small, with just a weird clunking noise or a kind of vague feeling in the steering. But that can quickly spiral into seeing your own wheel is misaligned, and then, the worst-case scenario, a sudden, complete loss of control. We are not talking about minor glitches here. These are the warning signs of a catastrophic failure. So what on earth is causing this? Okay, so let's get to the bottom of this. We're going to play detective here and use a classic technique called the 5 whys. It's actually really simple. You just keep asking why until you dig down to the absolute root cause. We're going to trace this problem all the way from the driver's seat right back to the factory floor. So let's kick it off with our first why. The most obvious question, right? Why is a brand new car at risk of just losing its steering? What's the immediate physical thing that's breaking down? The answer is deep inside the car's front suspension. Just think of the wishbone as this super strong arm that connects your wheel to the car's frame. And the ball joint is like a flexible knuckle that lets the wheel turn left and right. If that connection between those two parts fails, well, the wheel can pretty much do whatever it wants. That connection is absolutely critical for control. Okay, that is a terrifying mechanical failure. But that brings us to our second why. That connection is designed to handle immense forces. It shouldn't just fail. So why is it failing? And the answer is just unbelievable. The connection isn't failing because a part snapped or wore out. It's failing because the heavy-duty, high-tensile screws that are supposed to bolt it all together were never installed in the first place. They are completely, 100% missing from the car. How is that even possible? Modern car factories are these incredible places, full of automation and robots and countless checks and balances. So how does a car roll off the assembly line, missing screws that are fundamental to its safety? The problem here isn't the car's design. The problem is in the factory that built it. And this brings us right to our third why. We know the screws are gone. The question now is, how did they go missing? Why weren't they installed in the assembly line? Now we're really looking at the manufacturing process itself. And what investigators found was a devastating double failure. First, the automated robot that was supposed to install the screws just didn't. But the second failure is honestly even worse. The safety system, which is specifically designed to catch this exact kind of mistake, also failed. The assembly line should have ground to a halt. Alarms should have gone off, but instead, nothing happened. The car just moved on. You see, this safety system is built on a Japanese concept called poka-yoke, which basically just means error-proofing. And the idea is brilliant in its simplicity. Think of a kid's shape sorter toy, right? You can't put the square block in the round hole. In a factory, it means the assembly line physically can't move to the next station until a critical task, like installing these screws, is confirmed as complete. But in this case, the system was totally blind to the error.
So this leads us to our fourth why. We've gone from the car to the factory floor, and now we have to look at the digital brain that's controlling everything. Why did this critical error-proofing system fail to do its one and only job?
The culprit was found in the MES, the Manufacturing Execution System. This is the factory's central computer, the software that's orchestrating every single robot and every step of the line. And somehow, it had been misconfigured. The computer's programming was literally telling the line that installing these life-or-death steering screws was an optional step. So the safety system didn't flag the error, because the master computer told it not to even look for one. So the problem wasn't a broken robot or a faulty part. The problem was a ghost in the machine, a single critical error buried deep inside the factory software that then cascaded into this massive, real-world safety crisis. And this brings us to our fifth and final why. The absolute root cause of this whole mess. How does a multi-million-dollar factory safety software get programmed to just ignore one of the most critical steps in building a car? And here it is. The ultimate source of the failure was
A software update. Some engineer, probably trying to make the production line more efficient, deployed a change to the factory's code. But here's the fatal mistake. After making that digital change, nobody performed a physical validation on the very next car to make sure the code didn't have unintended consequences. They just trusted the software, and the software, well, it had a huge flaw.
You can just see how this created a digital domino effect. First domino falls. A software update gets pushed to the line. Second domino, that update accidentally creates a loophole, bypassing the safety check for the steering screws. And the final crucial domino to fall. The process was missing a mandatory physical check. Nobody was required to actually look at the first car off the line after the update to verify the digital change worked correctly in the real physical world. So now that we've finally found the root cause, how is it being fixed? Well, the response has to happen on two fronts. You've got to fix the cars that are already on the road, and you have to fix the process so this never, ever happens again. The response really has to be twofold. So first, you've got the immediate fixes, recalling all the affected vehicles, fixing the software, and auditing every single car still at the factory. But the second part, prevention, that's what really matters for the future. They are now mandating physical checks after any software update, adding new camera systems for visual verification, and requiring a dual signature approval, so two people have to sign off on any critical changes to the code. And they're adding one of the most interesting new preventative measures. It's called the Red Rabbit test. To make sure this never happens again, they will now deliberately send a car down the line with a known defect, like intentionally leaving those screws out, just to test if the safety system actually catches it and stops the line. It's like a scheduled fire drill for the factory's brain, constantly making sure that the checkers are still checking.
So when you boil it all down, this wasn't really a failure of parts or the people on the assembly line. As the official report puts it, it was a deficiency in the change management process. Basically, they got so focused on optimizing the digital world that they forgot the most important step, verifying the results in the physical world.
And that leaves us with a much, much bigger question, one that goes way beyond Peugeot. This was just one error, in one line of code, in one factory. But as our entire world becomes more automated, more reliant on software that we can't see, this whole story is a pretty chilling reminder. It forces us all to ask, in a world that is built and run by code, who is checking the checkers?